Let's go ahead and get started with the introductory portion of our webinar today. As I mentioned, this is the Ground-Based Radar for Mining Applications webinar. We have a great panel of experts here today to answer your questions. We really appreciate their time, and I want to make sure I thank them very much for being here today with all of us. I will introduce them in just a little bit. This webinar is brought to you by the Geotechnical Center of Excellence at the University of Arizona. If you're unfamiliar with the GCE, we are industry funded. We're also member led, and we are an interdisciplinary center. So we focus across a range of topics dealing with geotechnical engineering, with mining applications. We collaborate on our research and education throughout industry and academia with a goal of bridging gaps across fields of study. If you'd like to know more about the GCE, we'd be happy to chat with you at any time. Send us an email at gce.arizona.edu. And the panel that we have here today are all presenters in the GCE's Geotechnical Radar Monitoring course, which is an online professional development course that covers topics ranging from satellite-based SAR and INSAR to ground-based GB SAR and RAR, along with all of the capabilities, limitations, how to interpret the data, and many real-world case studies and examples included as well. So if you're interested in learning more about radar monitoring, you can check out that course. And I want to make a point to thank our member companies that help support the GCE. These companies make possible webinars such as this, as well as our professional development courses, and support the research efforts of the GCE team. So a big thank you to all of our supporting GCE member companies. And now I'll introduce who's here with me today. So first from the GCE, our webinar team today, myself, I'm Jillian Noonan. I'm a senior R&D engineer with the GCE, and I'll be your moderator today. Along with me, I have Julia Potter, who is the co-director of the GCE. Hello, Julia.
Hi, Jill. Thank you. And thanks to everybody for being here today.
And then also James McNabb will be helping to field the live questions coming in today. James is also senior R&D engineer with the GCE. James, thanks for helping out today.
You bet. Hi, everybody. Happy to be here, and thank you all for joining.
And Allison Brucey is the GCE's program coordinator. She will be communicating with you in the chat today and helping to manage the webinar. Thank you so much, Allison, for your help today.
Thanks, Jill. Thank you, everybody, for being here.
And now it's my pleasure to introduce our wonderful panel today, who will be fielding your questions on ground-based radar for mining applications. First, we have Derek Rubish, who is Senior Geotechnical Engineer with BGC Engineering. Derek, we really appreciate you being here with us today. Thank you.
Yep, happy to be here. Thanks.
And then I wanted to mention that Charla Coetzee was invited as an expert today. She was unable to join us, but I did want to mention that if there are any questions specifically for Charla on any of her content that is presented in the radar course, she is available to answer any questions on the course discussion board in the Geotechnical Radar Monitoring discussion board. So please feel free to forward any specific questions to Charla to the GCE or post on the discussion board if you're a student in the radar course. Also here today with us to answer your questions is Albert Cabrejo. Albert is the Global Practice Lead for Geotechnical Advisory with Ground Probe. Albert, we're so glad you're here with us.
Hello, everybody. Thank you for the invitation again. Pleasure to be here. Thanks.
Next, I have Cliff Preston. Cliff is Director of Mine Monitoring with IDS GeoRadar. Cliff, always great to see you. Thanks for joining today.
Yeah, pleasure to be here today. Thanks, everybody.
And finally on our panel today, we have Paolo Farina, who is the Managing Director of GeoApp. Paolo, thank you so much for joining and giving us your time today.
Hello, everyone. It's a great pleasure to be here. Thanks for the invitation.
So with that, I will welcome you at this time to start entering any questions you might have on ground-based radar applications in mining for our panel. Using the Q&A function, we will go through some pre-submitted questions that came in through the question form or the discussion board on the radar course site. but we'll be also accepting all the live questions that you might have. So feel free to go ahead and begin entering those at this time. All right, if our panel is ready, I will pull up the first question, which was received pre-submitted. So we'll start off with this question and I will read it out and then I'll invite the panel to unmute and respond. So our first question today is, when developing a mine site radar monitoring program, what are the most important factors to consider in selection of radar type and site for the radar? So a big question. We can start off with any volunteers to take a
I can
stab at that.
have a crack at it.
Paolo? Is that Albert? Yeah, Albert,
Yeah.
go ahead.
Okay, well, thanks for the question. There are many things to consider. The basic ones is visibility. How many radars radar systems will you need to cover the entire shape of your mine? So that's the first thing. Secondly, the type of coverage that you have on the surface. Is it rock? Is it loose materials? Is it vegetation? Stuff like, do you have water in the pit, like a big sumps at the bottom of the mine that would cause some degree of problems. From the geotechnical point of view or rock mechanics point of view, have a consideration about what are the expected mechanisms of failure: fast, rapid, brittle failures, or is it long-term deformation? Is it circular rotational failures, structural? If it is a structural type of failure, then where are you going to position your radar so that it can pick up the movement in the preferred direction, driven by the structures behind the unstable wedges? The money, of course, maintenance, communications. But another interesting point to consider, probably I will close with this one, is are you trying to achieve tactical real-time monitoring with lots of mining equipment around nearby unstable wedges? Or are you looking for a wide background monitoring long-term with alarms as well, but just hunting for instabilities all around that you may need to focus in a different way, with a different technique? I'll leave it there. For sure, there's more to talk, but I will let my colleagues to participate.
Yes, great. It'd be good to hear from all on this topic. Cliff, would you like to?
Yeah, sure.
Yeah.
I mean, I think I agree with everything Albert said, and there's just a lot of factors to consider. When you're looking at a slope and what your goal of the monitoring campaign is, and line of sight, the visibility, can you see that area? How close or far you want to be? What are all the areas you want to cover? Budget could play into that. Also, where's operations? So you don't have to put it somewhere near that you're going to have to move it often. There's just many things to consider. And usually what we recommend is, if you're in that stage of planning where you want to put radars and stuff, I would reach out to the vendors because they have a lot of experience doing this and they can definitely help you in explaining the different questions you may have about where you can put it and stuff like that. And I know many they also can show general coverage that you might get from different positions and stuff like that.
I
Yeah, I
can.
can-
Oh,
Go
sorry.
ahead, Paulo. No, I'll
Oh.
follow you, Paulo. Go ahead.
Yeah, thanks, Derek. So I fully agree with the previous speaker. I think it's a matter of also finding the optimal compromise, between the coverage you can get at the open pit in terms of number of units you need to get the coverage you want, and of course the sensitivity of the line of sight that you can obtain. Okay, because sometimes user tend to let's say focus on the coverage, but not considering too much that there could be areas where the sensitivity of the line of sight could be not ideal, and this should be, in my opinion, considered even using very simple geometric consideration or using information about the most likely expected failure mechanism. So that's an important point. Also, I think what is the working distance you are dealing with? Because when you are working a long distance, you may have issues with the resolution. I mean, if you are too far away, or with challenges with strong atmospheric artifacts. So these are elements to be considered. Another important point is if you are dealing, for example, with very brittle failure mechanisms that develop in a very short term with minimum deformation, it would be good, for example, from my experience, to install a radar close to the bottom part of the pit, close to the slope, in order to get the best resolution we can get, the best line of sight, and also to be able to measure even minor movements develop in 30 minutes, 1 hour. Okay, this could be important when you are close to production in order to prevent accident. But there are several factors, and it's a difficult, challenging question, I mean, to address in just also consider the stability of the radar, where you are going to install the radar. Okay, you can use other technologies that can help you with GPS, INSA, whatever, to be sure that the radar is installed in a stable spot.
Yeah, I completely agree with what everyone else already said, so I won't rehash all of that. But some of the things, there's kind of two parts to that question. There's the type, and then there's the sighting aspect. So relating to the type, you need to know what the equipment capabilities are, scan distance, extent, data resolution, what the scan times are. Those will help inform what type of movement and what movement rates you will actually be able to capture and alarm. And I think usability is also one of the ones that's often overlooked. It's important to have a system that you can train your personnel on, and for that matter, you have to have personnel that you can train and who's able to integrate with these units. So a system that's usable, it's understandable, and it's, I think it's important to mention that it's not a set it and forget it technology. It's something that needs oversight, it needs maintenance. It's a very, very eloquent tool in a toolbox, but it's something that needs to be wielded. In terms of locations, let's see, Albert, I think you'd mentioned the failure modes and mechanisms. So having appreciation for the sliding and toppling rotational failures, that might alter where you actually want to situate these units. It's going to, given that it's a line of sight technology, it's going to pick up those different types of movements in different ways. So understanding vector loss of movement and how that will actually be recorded on these units, I think, is important as part of that sighting assessment. And then site traffic and accessibility, you want to make sure you're not near blasting or hauling, or if you are, that you can turn these units off or decommission them temporarily. But you also want to have access for maintenance and things of that nature. So it is a process, a lot of things to consider, but I'll leave it there.
But if I may probably summarize key things: line of sight, coverage, as in vegetation, snow. You will need to think about alternatives if you have those type of surfaces on your pit, and the impact of operations. Those would be the key 3 ones. The rest, I'd say, pretty much all the radars have a way to manage with any other aspect of that we have mentioned before. But let's say if you want radars, make sure that they are deployed in a scenario where they can deliver the answers that you are looking for. Snow and vegetation are a big challenge. So that's probably the most important thing to consider, if radar is suitable or not, or to what degree it would be suitable.
That's good. That's good, Albert. It's actually a good lead in to another question we got, well, a couple of other questions we got on the effects of snow or other atmospheric noise. So unless there's any other comments on this one, we could move into that topic. I think you all summarized this fairly well at a high level, which it is a large question, but the information was presented well. Are there any final comments on this question before we move on to the topic of snow? So this also was a pre-submitted question. And the person submitting says, I'd be happy to listen to the experts' thoughts on the latest advancements and best practices applied to radar monitoring in winter conditions, extreme cold, snow cover, and snowfalls in particular, and other seasonal effects. Also, how does snow cover thickness affect the radio signal propagation? And I will open that to our panel.
Okay, I can
Albert,
have a crack at it.
sure, go ahead.
So, okay, winter conditions. Let's assume we are talking about winter in the areas with snow. The rest of the world, the winter is a rainy season. So let's talk about extreme cold, snow cover, snowfalls. So depending on the radar technology that you are using, you have the possibility of looking at the coherence parameter, coherence maps, coherence plots. So when I'm personally looking at data from mines with covered with snow, I try to find areas or pixels that have retained high coherence even during the storm, during the snow events. And I try to focus on those little spots that are still giving you high quality information, even if the rest of the mine is covered with snow. That applies as well to defining the stable reference areas. So you have to try to avoid having them created on regions of the mine where snow accumulates, because that will be affecting the atmospheric correction. Snow accumulation or snow melting will end up having an influence in the atmospheric correction, so could induce false displacements on the formation maps and plots. So in those complex scenarios, I always hunt for pixels of good quality through the coherence parameter. We have had, with a recent algorithm, precision atmospherics, we have had some good success at Bingham Canyon, for example, and Mount Wright in ArcelorMittal, Canada, during the snow periods, in which the algorithm managed to still produce reasonable data and maintaining the maps during the winter, some of the trends detected in the periods without summer. That is, I believe that is still a little bit let's say, not completely understood yet by us, but we have some good cases of success with this new algorithm. And finally, the snow, in general, if the snow is accumulating on the surface, the radio signal may penetrate a little bit of the first centimeters of snow. But if the snow is growing, basically, you will see movement towards the radar. When the snow melts down, you see movement away from the radar. So we try to focus as well on the crests of the benches with high coherence to conduct analysis in those scenarios. Thank you.
Thanks, Albert. Any additional comments from the rest of the panel? Cliff?
Yeah, I mean, I think that snow cover can be kind of complicated, in particular, just because, yeah, I mean, the radar signal, it affects it in different ways. And for many sites, I mean, there's a lot of sites that use radars in places that have snow coverage. And as Albert was saying, there's many cases where, yeah, you know, atmospheric algorithm can help correct for a lot of that. There's other cases when you have mass snow accumulation where it's not going to be as successful, and you can usually see that because you can see on your benches where snow builds up typically, you know, more of an effect, and where snow is usually not building up as much, less of an effect. So it's quite predictable, and it looks, you know, really different most of the time than displacement in a pit. But it's something important to be aware of, because certainly displacement could happen simultaneous to like snow building up, and it would make it difficult to interpret at that point, stuff like that. So it is important to pay attention to the snow, the weather in general. That can help you with this interpretation. But yeah, I mean, as far as the radio signal propagation in the snow thickness, you know, it kind of depends on the water content of the snow. And you know, the different layers sometimes as well. So it's difficult. It's difficult to exactly answer like what will, you know, in this scenario. Well, if there's a lot of ice, you know, that reflects the signal differently than dry snow, for example. So yeah, it's something that I think experience will show you when you are monitoring and you have snow events and you see, oh, okay, this is what the data looks like when I have snow, and this is the expectation I can have when I'm monitoring. Yeah.
Yeah. In my personal experience, most of the challenges when there is snow is during the melting season, because it's exactly when you have water infiltration, and this may trigger instabilities. And this is when exactly you may struggle with interpreting radar data, because the snow melting may generate some fake displacement, no? on your radar map. So that's exactly when you would like to have good data. But it's also true that when you have steep slopes, typically the upper part of the slopes are where the slope is steep, the angle is high, there is not that much accumulation. So you may have more noise in the lower part of the bench, but in the upper part on the crest, you can have good data. So if the resolution is good enough, you can somehow see this effect. And of course, the other issue is when during snowfalls, because snowfalls in general are generating, let's say, higher level of noise in your radar data. So this could trigger some, let's say, alarm, unexpected alarm. And of course, in general, we have to be careful now when there is snow accumulation or snow melting. You have to take more attention in interpreting the data, and sometimes you cannot get the same level of reliability. You need some kind of manual interpretation, or to filter out what could be a real alarm and from a fake alarm. So that's something that probably involve more efforts from the user points of view, and in my experience.
Yeah, from my experience, I think it requires a lot of observational judgment and correlation with visual inspections where possible. Now, obviously, if it's a whiteout condition, then that can be challenging. But having eyes on the slope, or having some sort of recording device where you can monitor visually what's going on and how that's manifesting in the radar data, as well as if you're seeing more global prolific changes across the entirety of the slope that you can correlate to a changing weather condition or accumulation of snow versus localized failures. Now you can get those as well with drifting and things with snow, but having that visual correlation, I think, is what we've relied on fairly heavily in terms of the performance of the radar and how it's manifesting in the radar data.
All right, thank you very much.
The good news is that typically users of radars in very cold extreme weathers, they used to say many times, I've heard, that during the winter, the walls freeze and the instability stop. So in that worst part of the winter, it seems like problems are less or reduced largely. But I agree with Paolo. When spring starts and the meltdown commences, that's when the water starts making its damage onto the slopes and becomes more challenging.
Yeah, I would also say kind of during that period, you have that freeze thaw cycle as well. So you can get ice wedging that, especially for brittle failures, can be a triggering mechanism.
All right, thank you, panel. I just want to quickly announce a new panelist who's joining us, Priyanka Narshai, who is from Geotech Mining. So as I mentioned, Charla was unable to join us today, and Priyanka is a geomatics engineer with Geotech Mining, working alongside Charla. So I want to thank Priyanka for joining us today on our panel.
Thank you so much, Jill, for adding me short notice, and sorry for being late, everyone.
No problem. We're really glad to have you here.
Happy to be here.
Great. Okay, I'm just going to transition into a live question that is in a similar theme to what we've been discussing. This came in. I'm sorry, that's not the one I wanted. Hold on one moment. There we go. Similar theme to what we've been talking about. This came in from Zip. So we may have answered some of this already, but if there's anything additional to touch on here, for the specific question, I'll pull it up. Zip has two weather-related questions. One, how do you manage or interpret atmospheric interference in the radar record for a brittle failure mechanism that calls for real-time dilation data for potential failure prediction? And how do you manage or account for snow cover interpreting the radar record, which we may have discussed. So any comments on this question from Zip that are in addition to this snow discussion we were just having? Paolo, go ahead.
I can try to address this. I mean, it really depends on the size of the moving area, and typically I would expect that a brittle failure probably is not covering a very large area. Could be bench, double bench, multi-bench, and typically atmospheric interferences that we experience at the mine site are covering a larger area. Okay, so of course you may have some noise in the data because of the atmosphere if you are in a bubble of atmosphere, but you may expect that relatively speaking, you can identify the displacement out of the atmospheric noise. So I think it could be hard in the automatic detection of movements, but then when it comes to interpret the prediction, it should be not that complex, okay? Because you will have an offset on your data. At least this is, if I understood correctly, the question. And I think the second part of the question, I think, was probably addressed in the previous part.
Yeah, and I agree with what Paulo said. Just some things to consider that we recommend as well is to just understand, how much atmospheric interference you usually have. Evaluate, like what is atmospheric influence I have, and then, what's our expectation for this failure? How big is it? How far away are we? Because these things all play a factor in this. And usually what it comes down to is that prediction is how long before the prediction, because of course, the instant before the failure, often it's pretty obvious because you have very high movement rates, even if it's pretty brittle. But, maybe hours before there was not much or no sign at all of a brittle failure happening. So, how soon is kind of the question that it comes down to, because you want to know as soon as possible that could be happening. And the more noise you have in your data, generally that means the later you're going to find out that failure is happening, because the early movements of the mechanism are going to be hidden, inside of some of that noise initially. So understanding how much noise you have at that position of where you expect the wedge failures, and then, how much time is that going to give you with how much noise you have from your expectation of failure rates and stuff like that. Yeah.
From my point of view, I think that it's fair to say that radars don't provide all the answers at all cases in all scenarios. There will be, for sure, 100% sure, there will be brittle failures that even without snow may not be detected by the radars, right? So if you add the snow to the complexity of the surface and the snow across the atmosphere, you increase the chances of not being able to manage some brittle failures with radars. In that case, SIP has been a good defender about the implementation of extensometers in real time, that if placed properly, would avoid any issue from that the radar may have. But this is a radar curve, so let's leave the other instrumentation on the side. So limitations from the radars, yes, sometimes you cannot manage those ones with that snow conditions, but sometimes you can. It may depend, as Cliff was saying before, how long has been the trend? If it is brittle, maybe not too much, but what is the trend outside the area that is that is moving? How is the noise? What is the noise pattern? What is the noise footprint versus what is the noise footprint on the area that is moving, the little wedge that is moving? Sometimes you can see those movements. We see that type of behavior as well on vegetated slopes on tailing dams in Brazil, for example. You see noise all the time, but sometimes you see certain patch of noise that keeps growing to you. So growing and moving towards the radar, like a back and forth type of movement because of the vegetation, but always moving forward in a different sort of noisy pattern. So it's not easy. It's not always resolvable through radars. Sometimes it is. So it's one of the limitations to consider when using radar technologies.
I think just also another note just on snow events and also other weather events. It's just good to keep record of when those events occur and correlate the time at which these events happen with your radar data for record keeping.
All right. Thank you, Zip, for the question. Thank you, panel. Any additional comments on this one before we move to another live question?
Check the coherence parameter. That's a good one again for snow.
Check the coherence parameter, you said?
Yes.
All right, I'm going to bring up another question that has been rated highly on our Q&A. This question comes from Saeed, and it is asking, how reliable are Chinese manufactured slope monitoring radars? Cheaper slope monitor radars are being offered by Chinese manufacturers in 1/3 the price of the international manufactured radars. What are the important features that need to be looked at while purchasing a radar? And now I know many of you are vendors of radars and may not be able to speak to other vendors' radars and the quality of them, but if there's anything you'd like to comment on here experientially and or just touch on the second part of the question about what are the important features that need to be looked at. So anyone from the panel like to start? Paolo?
Yeah, I can start because I've been exposed to several times to Chinese radar in the recent past. Normal, let's say, synthetic aperture radar or MIMO radar, so electronic arrays. I think from an hardware point of view, of course, this radar, they are new to the market, so we cannot, let's say, judge, in my opinion, how reliably they are, because they don't have the track of the we have from other radar manufacturers. So that's something, in my opinion, should be figured out in the future. From a technical point of view, my experience is that these radar are very good because in some cases are very similar to the radar available on the market from a Western supplier. The electronic array system is new, but it seems to be a very good technology. Of course, again, if you try the system to measure in the short term, you can say that the quality is good, then it comes to evaluate over the long term in harsh environment and so on. So something that, at least from my personal experience, is out of, let's say, not yet checked in, let's say, standard environments out of China, because in China they are already pretty active, okay? But you know, the requirements or the level of the judgment level of quality in China could be different from out of China, so I cannot judge. It's true that the price is lower. I don't know if it's 1/3, but it could be lower. And my feeling when I try this radar is that from a software point of view, from a processing point of view, they are still a little bit behind to what I've been exposed to other, let's say, more consolidated radar vendors. So this is probably a gap that they could recover, but it is still a gap. That's my personal experience.
Thanks, Paolo. I also want to note that in the question, in the Q&A, if you click on Q&A, you can see that one of our participants has also provided some responses there. And I wanted to share that any of our webinar participants are allowed to type in the questions and also respond to other questions if you have some input that's valuable in addition to what our panelists are talking about today. So thank you, Alexi, for adding some information there. Any other comments from our panel on this question?
Yeah, I have a comment. When we are surveying our customers for what is important to them when buying radars, the two key parameters is first is so it varies between first service, second the technology itself, or the opposite. First the technology, the capabilities, second the service. Price typically comes at the third place. So you can have a great technology, but if the support is not there, you don't have a product, all right? And radars, from my experience, radars are typically a type of technology that requires good support from the vendors, on-time support, 24/7. That comes at a cost that is, let's say, priced at the local prices in the country where you are operating. So I'm sure that the technology-wise, they can be good. Mats are the same in China or in Colombia, my country, or whatever. Mats are the same. Processing is the same. They produce processors and technology in China. At some point, they will pick up with any lack in terms of the quality of the technology or quality of the mathematics or processing. They will pick up on that for sure. They produce iPhones, as I understand. So I think that the challenge would come from the financial muscle that these new companies may have to support 24/7 a global market. We have seen that as well with other attempts from other vendors in the past to produce radars. And finally, as far as I'm aware, and kind of alluding to what Paolo said before, they are doing synthetic aperture and MIMO technologies. They are not producing real aperture technologies. And again, in our ground probe experience, the real aperture radars still have a role to play. So this part of the role to play is not being addressed by these Chinese manufactured radars because they are producing a different technology. That's it. Those would be my comments.
Yeah, and I think I'll just add that I think it's important when we look at the radars and you're evaluating it. So what are the important features? And like Albert said, there's the software, there's the hardware, and then there's the support and life and how you're going to use it and maintain it. And all of those are really important factors when it comes to purchasing a radar and something that you should give equal weight to looking at closely, really. I mean, a radar that you purchase that doesn't have the support and ends up breaking and then spending a lot of time down because they don't have parts in country or whatever it may be. We see a lot of stuff like that happen, and you end up with initially a cheaper price, but in the long term you're getting a lot less out of that too. So just important things to think about.
Good points. All right, thank you for the question, and I'm going to move on to another. And thank you, Derek, for typing in an answer to one of the questions in the Q&A for Alpha. The next question I'm going to bring in up is from Marco, and it is on the topic of performance-based design and radars. So hi, panelists. Thanks for taking the time to answer our questions. I'm curious about designing based on ground performance. If you don't have multiple radars monitoring the same wall, how can radar data be used to provide feedback for geotechnical assessments that are performance-based, specifically regarding slope deformation for performance-based design? Is complementary surface instrumentation essential for accurate deformation calibration using radar data when limited radars are available for monitoring the same wall? Or what have other minds done in your experience regarding performance-based design? Thanks. Any of the panelists like to start with this question? Paolo.
Yeah, I'll try to address this. It's a complex question, but I mean, there are not too many sites, to my knowledge, that are using, let's say, radar data in order to, let's say, compare how the slope is performing compared to the, let's say, the performance-based design of the pit. In theory, in my opinion, it is possible to use also radar to do this, because radar is just measuring a line of sight, but in the end, you measure displacement along the line of sight that could be converted into deformation, okay? Because you have the displacement, loss displacement divided by pixel size, and in the end, with some calibration, as probably Marco is referring to in the lower part of the question, you could try to get the deformation, or at least with one radar, you will have an estimation of the deformation along that direction. which could be, in my opinion, let's say, from the three deformation component, north, east, and vertical, you can get, if you have from modeling those three, you can get what could be from this line of sight for each pixel, what could be the line of sight deformation. We are doing this, for example, with using INSAR data, of course, for long-term deformation, not for, let's say, fast movement, because INSAR at least has two, let's say, vertical and east-west. Of course, you don't have north-south, so you may miss that part. And with the multiple radar, in theory, by integrating two or even better, three line of sight, you can get the three-dimensional deformation field. But that's something is happening because most of the modeling nowadays is changing. Is passing from, is an open, is a hot topic. Let's say we are moving from factor of safety toward, let's say, critical limit of strain. And of course, why? Because strain is something you can measure, and it's easy, is the first outcome of any numerical modeling. While factor of safety pass through the application of a failure criterion, more column or any other. And of course, this is introducing a lot of, let's say, uncertainties. But of course, the factor of safety is a number, is a well-accepted number, even if it's could be pretty, the reliability of the factor of safety could be pretty low. We know very well that it's accepted, and everyone now, even the regulator, are referring to factor of safety. So that's why the move of modeling and stability assessment from factor of safety to critical value of strain is still a little bit behind. But at the slope stability conference back in April in Brazil, there was a very interesting presentation from Derek Marty, and Derek, in my opinion, clarified very well how we should move forward in that direction. So I don't know if I addressed the question, Marco, but that's my input.
Thanks, Paolo. I see
Yeah,
a thumbs up.
one thing to be very, very mindful about is that radars, ground-based radars, they are inside the pit typically, or at the crest of the pit. So there was a rock mass there, somebody excavated it. So what the natural reaction is that it will try to close. And radars use the surface inside the pit with different techniques, but they use the surface that is deforming itself as references for atmospheric correction in order to detect other areas of movement. So keep in mind that radars will always be measuring differential deformation inside the pit. What is deforming the most versus what is being considered stable. But in principle, in many cases, you would say nothing is stable inside the pit because it will try to close itself over the long period of time. So radars are not an absolute metric, or don't give you an absolute metric of displacement. Those are better obtained through other techniques, including the real vectors of movement. Radars only give you one component. If you have three radars pointing at the same slope, which is quite expensive to do, but is doable, then you could have vectors of movement from the radars. But there are cheaper ways to do it, but through presence or GPSs, I'd say. So keep those things in mind if you try to do some assessment on the performance of your pit using radar data versus your designs. And when you do that reconciliation, keep in mind that you are looking at different vectors of movement or different magnitudes. Other instrumentation, I believe, is essential. I am completely certain about it. You cannot do all of this just thinking or looking at radar data. INSAR data, presence, extensometers, inclinometers, piezometers, everything should be taken in account for the analysis of your mine and designs and how successful they were, and what changes you may need to introduce in order to get your mine back to compliance to the performance that is expected. That's it. Good question. Difficult.
We wouldn't expect anything less from Marco. Cliff, did you have something to add?
Yeah, I was just going to echo what Albert said, really, is that, normally I'd recommend having some other instrumentation to help calibrate, the radar magnitude because you don't know exactly what direction it is with just the one radar. So it's hard even with the angles to say this is how fast exactly I think it's moving to use that, for calibration purposes. I think that's pretty important, but definitely an area that I don't see a lot of people, doing this, Marco. So it's an area that can be, for advanced users, definitely more exploited, is going back to the modeling. Yeah.
I would also add that if you're using multiple technologies, which we would definitely advocate, you may have different thresholds for those different types of monitoring systems. What's applicable for a radar unit may not be applicable for a prism given the vector loss of movement. So it's important to evaluate, have an appreciation of the overall slope movements, rates, but also how those translate to the various types of instrumentation and how you might end up actually alarming on each of those types of instrumentation if that's the end result.
Great. All right. Thank you, panel. And thank you, Marco, for the great question. We'll pull up another live question here that has been rated in the Q&A from Alpha. What advice do you have for mining investors with less appetite in investing on radars for slope monitoring? Any advice from our panel?
It is very sad when I play a commercial role as well in ground from a technical point of view. When you are trying to promote your radar technologies to customers, and they say no, we don't need that, and then you see a fatality on site, and then you see the reluctant customer rushing to get radars and put everything in place after people have died. It is sad. It is just not acceptable. I think that for the money that a mining company produces, the price of a radar, and especially compared to the lives of the people, is nothing. It's nothing. I'm not saying just plug the mines with 15 radars per mine. No, not to that point at all, of course. But I think radars are part of the essential toolkit to keep the people safe and even alive in the mines. There should not be questions about it, in my opinion.
If I can add something on top of this, I think the radar are not, let's say, essentially everywhere. Okay, so it really depends on the risk level we are dealing with. So it's important that the design of the slope monitoring program does consider what is the level of hazard we may have at the mine site, and based on this and along the life of the open pit, because there could be periods where the height of the wall, the slope angle, the bench face angle, the interrupt angle are not that steep, and so this probably there is no need of a real-time monitoring system like radar. You could start with a different technology. Then, of course, you will see also based on the everyday experience when it is the time to move forward to, let's say, introduce a more sophisticated system, of course, more expensive, but also capable of allowing you to operate in a safer way when the conditions are less, the hazard level is higher. So I think it's important to design the slope monitoring program in the right way without let's say, shooting at the beginning, or when there are no, from a geotechnical perspective, there are no expected challenges. So you can deal with prism, total station, a few geotechnical sensor, and so on. And then, of course, be prepared to, and also plan for, let's say, more complex monitoring system, integrating one radar, more radar, INSAR as well, when the situation, of course, is different. That's my personal recommendation. So the design of a monitoring program is a serious engineering process and needs to be to some level of expertise, into the company, if there are experts into the company from other sites or at corporate level, or from external consultants that have enough experience. So that's my recommendation, of course.
Yeah, and just to add, like what Paolo and Albert saying, I mean, yeah, it really comes down to the design, of the slope of the pit and the slope monitoring program that you have, because I mean, you don't need radars everywhere. You could design a very shallow pit that's going to be very inefficient for you from the investor side, and it will be unlikely that you would need maybe a slope monitoring radar in that case. So I think it really comes down to also looking at, like, when we do design this in our slope monitoring program, many times adding the capabilities of a slope monitoring radar will, give you better safety and also allow you to mine more efficiently and, easily pay for that cost as well. So I think it's just from the investor taking a close look at, that business case and those business cases, and also understanding, like, the slopes, the risk, the slope monitoring program that we're designing, the experts that we're using, and putting all that together. I don't think it's really about, like, avoiding slope monitoring radars necessarily, because I guess you could apply that logic to any slope monitoring equipment. It's just designing a program well that's going to meet the safety need that the site has.
Well said, Cliff. Okay, we have just a few minutes left, so I'm going to bring up one final question, and I'll just ask our panel to comment in, less than 1 minute each, 30 seconds or less each. Just on this final question to close out, I know we have a number of representatives from different companies here today, and so I'd love to hear your input on what developments or trends do you foresee in the future for geotechnical radars for mining applications? And this question comes from Mauro. Thank you for the question, Mauro.
Integration with other technologies, as not just for visualization of different data on top of the other, but crossover of information and simultaneous or let's say cross-pollination between information provided by different techniques.
Yeah. I would also add, like, better alarming tools, better back analysis tools. I think all these types of things are going to help a lot from the technological innovation point of view. Yeah.
Any other comments, Derek?
Yeah, I would just
Go
Let's do Derek, then Priyanka.
Sure.
Yeah.
Yeah. And I think Albert touched on this, but just better overall geomatics information integration. There's a lot of platforms out there making sure that there's a lot of synergy between the different data sets coming in, and you're able to overlay and interpret multiple data sets in near real time to the extent possible, because the better picture that you have of what's going on, the better you're able to react and respond to those various situations.
And Priyanka?
I think also just improving on hardware and reliability is also something really important to us. And I agree with Albert about integration of sensors and looking at other third-party applications and just looking at better removal of atmospherics and things like that.
Great. And I will mention that we had a lot of questions come in today. If we didn't get to your question, we do have an additional webinar coming up on May 22nd that's open. It's going to be focused on radar data integration. So just as Derek and Priyanka were just speaking about, we'll be discussing topics on how to integrate your radar data with other systems and monitoring platforms and things like that. So we'll be accepting questions on those topics May 22nd. So make sure you register for that webinar. I want to say thank you very, very much to our panel today. We really appreciate you. All of our participants appreciate you and your time today. So thank you for being here. And then if you are interested, in learning more from these experts through the radar monitoring course. You can check out this QR code here. It's currently available online as a professional development course where you can learn all about all the topics today and have additional access to these experts that are on our panel today. So thank you so much, everyone. We are at time, and I really appreciate you all. Have a great day, and we'll see you at the next webinar.
Thanks, everyone.
Thank you, everyone. Bye-bye.